Okay, good day everybody. I'm gonna talk about the trace minerals. And by the word trace minerals, we mean that those minerals which are present in amounts less than 5 grams. Major minerals are those minerals which are present in the body in amounts larger than 5 grams. So as you can see in this chart, the trace minerals include iron, zinc, copper, manganese, iodine, and selenium. We will start with the iron. We have two forms of iron for the body benefit. We have that iron which is used by the body to build hemoglobin. We call this the heme iron. And the non-heme iron is that iron that it is used in the body in other functions besides the formation of hemoglobin. We call them the non-heme iron. Only the foods derived from animal sources provide the heme iron, but also they contain non-heme iron. And all the iron in foods derived from plant sources is the non-heme iron, which is not going to be used by the body to form hemoglobin. Factors that enhance non-heme iron absorption are the MFP factor. This is number one. MFP factor is a peptide released during the digestion of meat, fish, and poultry. And you will notice that MFP is taken from the first letter of the words meat, fish, and poultry. And this MFP factor enhances the non-heme iron absorption. Factors that inhibit the non-heme iron absorption include calcium, phosphorus, and tannic acid. Tannic acid is present in the tea, and that's why it is advised not to drink tea after eating a meal. At least leave a gap of 2 to 3 hours. Iron in the food is absorbed through the small intestine. Part of it goes to the blood, and part of it is stored in the intestine in the form of ferritin. If the body does not need iron, iron will be excreted and shed with the shed intestinal cells. Mucosal ferritin in the intestine releases its iron to the blood whenever the body needs iron. Iron recycling. Some losses via the sweat, skin, and heme should be compensated by ferritin, mucosal ferritin in the small intestine. And when the mucosal ferritin releases its iron, it goes to the blood and it is carried in the form of transferrin. Transferrin is the transport form of iron in the blood. And then transferrin releases its iron to the tissues which needs it. For example, the muscles for the synthesis of myoglobin, the bone marrow for the synthesis and the formation of hemoglobin in the red blood cells. The fate of the red blood cells is in the reticuloendothelial system, in the liver, in the spleen, which breaks the aged RBCs when it reaches the end of its lifespan, 120 days. In the liver, it is broken down to release iron again, and this iron can be reused again. That's what we mean by iron recycling. High-risk individuals for iron deficiency include women in their reproductive years, pregnant women, infants and young children, teenagers. Stages of iron deficiency. When the iron is not enough in food, iron stores in the intestine begin to diminish, and transport iron diminishes after the depletion and the emptying of all the iron stores in the intestine. And after this point, hemoglobin formation becomes affected and we get anemia. These two pictures compare the size and the color of the normal red blood cells in the upper picture, and the lower picture shows an iron deficiency anemia. Notice the color, notice the size of the red cells, compare it with the normal picture. In 2001, the RDA for iron in men was 8 milligrams per day, and for women in the age between 19 and 50 years, which is the reproductive age, is 18 milligrams per day. And above 51 years, the requirements diminish to become like males, 8 milligrams per day. Upper level for adults, 45 milligrams per day. Significant iron sources include red meats, fish, poultry, shellfish, eggs, legumes, dried fruits. Chief functions in the body: hemoglobin and myoglobin formation, and necessary for the utilization of energy as a part of the cell's metabolic machinery and energy productive systems. Deficiency leads to anemia, and anemia manifests by weakness, fatigue, headaches, impaired work performance and cognitive function, impaired immunity, pale skin, pale nail beds, pale mucous membranes. It can be seen in the tongue and in the conjunctiva, and the palm creases with concave nails. Pica means abnormal appetite. And finally, inability to regulate the body temperature. Toxicity of iron leads to GIT stress, iron overload, which is stored in the liver and can lead to liver malfunction. It gives fatigue. It can lead to infections due to depressed immunity, joint pains, and skin pigmentation, and finally organ damage like liver damage. Iron in food, it's present significantly. You can see in the tortilla flour, enriched in the potato, and in the pinto beans, and in the canned clams, beef liver, and parsley. These are the rich sources for iron. Zinc. Zinc is similar to iron. Zinc is stored in the small intestine, in the mucosal cells, in metallothionein, and whenever the body needs, the metallothionein releases the zinc to the blood, and if the body doesn't need zinc, it will be shed with the falling intestinal cells. In 2001, the RDA in men was 11 milligrams per day, and in females 8 milligrams per day. In the upper level for adults, 40 milligrams per day. Chief functions of the body: it's part of many enzymes. It is associated with the hormone insulin, involved in making genetic material, the DNA, and proteins. It's involved in immune reactions, transport of vitamin A, taste perception, wound healing, and the making of spermatogenesis and the normal development of the fetus. Significant sources include protein-containing foods, red meats, shellfish, whole grains. Deficiency leads to growth retardation, delayed sexual maturation, impaired immune function, hair loss, eye and skin lesions, loss of appetite. Toxicity gives manifestations like loss of appetite, impaired immunity, low HDL cholesterol, copper and iron deficiencies. The sources in foods of zinc: we find significant sources in the broccoli, in yogurt, especially the plain yogurt, ground beef and lean meat, as well as in oysters, lean, and crab, the seafood in general. Iodine. 2001 RDA for adults, 150 microgram per day, and the upper level is 1100 microgram per day. Chief functions of the body: it's a component of two thyroid hormones, the T3 and the T4, that help to regulate growth, development, and the metabolic rate. Significant sources in iodized salt: seafood, bread, dairy products, plants grown in iodine-rich soil, and animals fed on these plants. Deficiency gives simple goiter, and goiter means enlargement of the thyroid gland, and in children it gives cretinism. Deficiency symptoms include underactive thyroid gland with a goiter, which is enlargement of the thyroid gland, mental and physical retardation in infants, which is called cretinism. Toxicity gives underactive thyroid gland, elevated TSH, and goiter. Selenium. RDA for adults in 2000 was 55 microgram per day, and the upper level is 400 microgram per day. Chief functions of the body, it's an antioxidant and regulates the thyroid hormone. Significant sources: seafood, meat, whole grain, vegetables, and this depends on the soil content of this mineral. Deficiency predisposes to heart disease characterized by cardiac tissue becoming fibrous, fibrosis. This is called Keshan disease. Toxicity leads to loss and brittleness of hair and nails, skin rash, fatigue, irritability, and nervous system disorders, and garlic breath odor. Copper. 2001 RDA for adults 900 microgram per day, and the upper level for adults is 10,000 microgram per day, which is 10 milligrams per day. Chief functions of the body is necessary for the absorption and use of iron in the formation of hemoglobin, and it's part of several enzymes. Significant sources include the seafood, nuts, whole grains, seeds, legumes, and deficiency symptoms is manifest by anemia and bone abnormalities. Toxicity leads to liver damage. Manganese. In 2001, adequate intake in men is 2.3 and in women 1.8 milligram per day, and the upper level for adults is 11 milligram per day. Chief functions in the body, it's a cofactor for several enzymes. Significant sources include nuts, whole grains, leafy vegetables, and tea. Deficiency is rare, and toxicity symptoms mostly affects the nervous system. Fluoride. In 1997, the adequate intake in men was 3.8 milligrams per day, and in women 3.1 milligrams per day, with an upper level for adults 10 milligrams per day. Chief functions involved in the formation of bones and teeth, and helps to make the teeth resistant to decay. Significant sources in the drinking water: if fluoride is added to the tap water, also it's present in tea and seafood. Deficiency leads to susceptibility to tooth decay, and toxicity gives fluorosis with pitting and discoloration of teeth. Chromium. The adequate intake in men 35 microgram per day, and in women 25 microgram per day. Chief functions of the body: it enhances the insulin action. Significant sources include meat, especially the liver, whole grains, brewers, yeast. Deficiency gives diabetes-like condition, and there is no known or recorded toxicity for chromium. Molybdenum. In 2001, the adequate intake for adults was 45 microgram per day, and the upper level for adults is 2 milligrams per day. Chief functions in the body: it's a cofactor for several enzymes. Significant sources include legumes, cereals, meats, and deficiency is unknown, and toxicity none. No toxicity for molybdenum. While in animals, reproductive effects have been recorded. Other trace minerals, just to know their names: nickel, silicon, and vanadium. Contaminant minerals. There are certain minerals like the most common, the lead, which can lead to toxicity. Lead is a heavy metal. It's similar to minerals. It gives rise to toxicity symptoms, which are cumulative, and because lead, when it enters the body, it's very difficult to get out, and it needs chelation and chelating factors in order to remove it from the body. Symptoms of lead toxicity in children include learning disabilities, low IQ, behavioral problems, slow growth, iron deficiency anemia, dental caries, sleep disturbances, nervous system disorders like seizures, convulsions, slow reaction time, poor coordination, impaired hearing. In adults, it gives hypertension, it gives reproductive system complications, and renal failure. Phytochemicals. Phytochemicals are plant chemicals which have a lot of health benefits to our bodies. They are not vitamins, but they are chemicals of plant sources. Just take examples from this table. We have the capsaicin, carotenoids, curcumin, flavonoids, indoles, isothiocyanates, lignans, monoterpenes, and organosulfur compounds. And we found these phytochemicals mostly found in the vivid colored vegetables and fruits. They defend against cancer and they defend against heart disease. Many of them are antioxidants. So phytochemicals are plant chemicals, not vitamins, but they are plant-based nutrients. We have hundreds of phytochemicals being studied nowadays. Many are believed to have major positive impact on the human health. Some of them are responsible for the bright and vivid colors found in fruits and vegetables. Thank you very much.